Hey guys, I'm really glad you came to tutoring today. Okay, we're going to review all of Chapter 3. In Chapter 3.1, we're introduced to linear systems, which are two linear equations that have an intersection point to make both equations true. To solve the system using your calculator, the equation must be in slope-intercept form. From there, you can plug it into your calculator, find the intercept, and then with the intercept, you plug it back into the system to see if it works. You can also find out how many solutions are in the equation after graphing it. Intersecting lines have one solution. Overlapping lines have infinitely many solutions. And parallel lines have no solution. Got it? Okay, good. Now we're going to move on to Chapter 3.2, Solving Linear Systems Algebraically. Okay, there are two methods for solving linear systems, substitution and elimination. To solve using substitution, you must solve for one variable in terms of the other variable. Next, you substitute that variable into the other equation and solve for the remaining variables. Then plug in that answer to solve for the variable from before. And ta-da, that's your answer. To solve using elimination, you create opposites to entirely cancel out one variable. Then you solve for the remaining variable and substitute in that value to solve for the other variable. On to Chapter 3.3, Graphing Systems of Linear Inequalities.
But wait, what's an inequality?
An inequality is a system of linear inequalities is just like a linear system, except the equal sign is replaced with these symbols. With linear systems, the same rules apply. When graphing, shade according to the symbols. You can use the test point 0, 0, but if it's on the line, use a point within the area. Depending on the symbol, you must use a certain line. If the symbol has a line underneath it, you must use a solid line. If the symbol does not have a line on the bottom, you use a dashed line. Now, if you want to save your teacher, you have to solve the system of linear equality for a potion.
How do we do this? Oh wow! We already solved it.
Shit! Now that you know how to solve systems, here's something harder. Matrices.
Wait, what are matrices?
Guys, it's me, Miss Gonzales. I'm in Math Magic Land. I don't have much time to say this, but when you add or subtract matrices, you should combine the terms with terms in the same rows and columns. Multiplying matrices by scalars is just like the distributive property. When multiplying two matrices, you add and multiply rows by columns, and make sure the dimensions match.
Okay, so since there's a negative here, we have to distribute it. And now you simplify. Another function. There's another one? Come on, April, we can do this. Now the dimensions match. They're both 2 by 2s. And Miss Gonzales said we multiply rows by columns. Okay.
So 1 times 5. Okay. 4 times 9. 4 times 9. Hey, don't you put a plus on it? Oh, yeah. Okay. 3 times 5. 2 times... And 9 plus negative 2 times 9. Do 1 times negative 7 plus 4 times 6. 4 times 6. Let me do 3 times 7. 3 times negative 7 plus negative 2 times 6.
Now we just simplify. Once you've simplified it, your answer was
41, 29, negative 3, negative 32.
Good. There's also something called a determinant. Here's a clue.
Hey, to do the determinant, don't you do AD minus CB? So,
that'd be 1 times negative 2.
1 times negative 2 is negative 2.
Minus 3 times 4, which is 12.
Minus 12. So that will be the determinant for this one once we simplify. And this one.
5 times 6 is 30. 9 times negative 7 is negative 63.
So when we simplify, negative 2 minus 12.
And now we multiply them.
We get negative
1,302. Yay!
Aha! But there's also something called the inverse. The inverse can be used to solve with a matrix to solve another matrix or a linear system. To find an inverse, you must multiply the matrix by the negative first power.
Yeah, you press second negative 1.
Oh, okay, here. I actually have one.
Okay, I'll solve it. Aha!
Liar function! You found another way!
Miss Gonzales, where's our A?
Oh, let me check. Let's see. Add in April, you all have 89.99%. And I don't round.
What?
Are you kidding?